Okay, the first thing I want to do today is I want to do a little practice graphing a single inequality on the graph, and I think you should have seen this before, but it's good to review. So I'm going to start by getting y by itself in this inequality. I'm going to subtract 2x from both sides, and I get 10 minus 2x is less than or equal to 5y. Then I need to divide both sides by 5. I've been noticing a little bit of issue with this. Make sure that you do the 10 divided by 5 first, and that's 2, and then do the negative 2x divided by 5, which is minus 2/5 x. Over here, 5 divided by 5 is 1, so I'm left with just a y over here. If I rewrote this as with the y first, I would write y is greater than or equal to 2 minus 2/5 x. So this looks like a y equals mx plus b at this point, and so I know I have the tools to graph that line. My y-intercept is at 2, and then my slope is negative 2/5, so down 2 over 5, down 2 over 5, down 2. You can kind of follow that pattern up also. Okay, since this is an or equal to inequality, that means that my graph has to represent the fact that I'm including the line. So this means that I have to have a solid line. So I'm going to take my solid line and I'm going to connect these dots. Just fix that a little bit. There we go. Okay. Then the next step is to figure out which side of the graph to shade. Do I need to shade up here or do I need to shade down here? So that's the question at this point. What I'm going to suggest you do is I'm going to suggest you put in a test point. My favorite test point is the point 0, 0, because it usually is not it's usually not a point that goes through any of the lines, but also it just makes the calculation really easy. So I'm going to start with just putting in the 0 for x and the 0 for y. That's the other thing, is then I don't have to remember anything about what I'm doing. I'm just putting 0 in for the variables. So then I get 0 is greater than or equal to 2 minus 2/5 times 0. So I get 0 is greater than or equal to 2. Is this a true statement? 0 is greater than or equal to 2? Is that a true statement? No, it's not a true statement. This is false. That means that this point right here can't be in the inequality. So this point is not a solution. So if the side over here is not a solution, then that must mean that over here is a solution. And so everything in the yellow that I just shaded, and I guess it goes out further this way, right? All of that stuff up there is my solution. I'm going to do exactly the same steps, but I just have to do it twice because I have two inequalities to graph. I'm going to go a little bit faster this time. Since this is an inequality that just says less than, that means that I'm going to use a dotted line. And that represents that the line isn't part of the solution that I'm graphing. So here's my y-intercept is 7. Slope is 1/2 x. Like that. So then I can kind of just connect these dots in a dotted line. Where is the graph greater? So I'm going to use a test point. So I'm going to put in 0 is less than or equal to 0 plus 7. Wait, 0 is less than, excuse me, 7. Is that a true statement? Yes, it's a true statement. So all of the stuff down here where 0, 0 is in the solution. So I can shade all of this stuff down here. So I'm going to highlight this a little bit so that we remember which one's which. The next step is to do the same exact thing with the next inequality. So where is x equal to 2? So what's that line look like? The next line is this one. This one actually isn't in y equals mx plus b, it's in an x equals, and that kind of is a little bit confusing because I don't see that a lot, but I'm thinking, okay, where is x equal to 2? X is equal to 2 here, because this is the point 2, 0. X is equal to 2 here because this is the point 5, 2, 5. This is the point 2, 10. All of these places, the x value is 2, here, here, here. So that must mean that all along this line, x is equal to 2. I'm using a dotted line again because it says or, it does not say or equal to, so this is a dotted line. And again, I can use a test value or a test point to see which side to shade. So I'm going to put in 0 for x because that's my favorite test point. 0 is less than 2, that's true. So that means that I need to shade all on the side where the 0, 0 point is. And so I'm going to shade all of this stuff over here. All the way up until we get to the line. Okay, where is the section of the graph that is shaded by both inequalities? I'm just going to kind of outline it here. It's all of this stuff. And it goes further than this. It goes all the way down here, all the way over here, and then it kind of continues on forever. So all of this red highlighting that I'm doing right now is in our solution. Super similar process here. The only thing that I'm noticing here is this one is not in standard, or is not in y equals mx plus b, which means that I will have to solve it for y to get it into that form so that I can graph it more comfortably. So I'm going to start by subtracting 2x from both sides, and I get negative y is greater than or equal to negative 3 minus 2x. Now I got to divide both sides by negative 1 to get y by itself. You should be saying, whoa, Mr. Nelson, I'm dividing by a negative number here. That means that I have to do something really specific to my inequality, and that means that I have to reverse the inequality. I have to say it's not greater than or equal to now, it's less than or equal to now. So I get y is less than or equal to 3 plus 2x. Okay. Y-intercept is 3, slope is 2. This one is going to be a solid line because it's or equal to. So I can connect those like this. Make sure to extend that line all the way across as far as you can, like that. Okay, which side of this line do I shade? Use a test value, test point. So I'm going to put in 0, 0. 0 is less than or equal to 3. Is that a true statement? It sure is a true statement, so I'm going to shade on the side that has the 0, 0. So that's all of this stuff. The next one is already in y equals mx plus b, so I can just graph that. So the slope is, or the y-intercept is 1, slope is negative 1/2. This one also says or equal to, so I can graph it with a solid line. Like that. Use a test value to determine what side of the graph to shade. So I'm going to put in 0, 0. So I get 0 is greater than or equal to 0 plus 1. So it says 0 is greater than or equal to 1. That is false. So I don't want to shade down here where the false stuff is. I need to shade on the other side, which is up here. That means that the solution to my graph, my inequality, is all of the stuff that is shaded by both inequalities, and I'm going to highlight that stuff right here. And it goes on forever in both directions and all the way over here. So all of this stuff that's shaded in red is my solution. I just wanted to throw it out there that absolute value is fair game for these inequality systems. And so I'm going to start by graphing this absolute value one so that we make sure we have a little practice with that. This is going to be a dotted line that I'm going to create. I can look at H and K. H is 3 and K is -2. And I can find out that the vertex is at the point 3, -2 right here. If you don't believe me, remember that this is a translation right 3 units and this is a translation down 2 units. Then this scale factor says that my scale factor is a vertical stretch. Scale factor A equals 2. So what that means is from the vertex you count almost like a slope on the right side. Gets stretched out like this. And then on the left side you mirror that over here. If you're struggling with this, you can always use Desmos. You can always use your TI-84 on your Chromebook and see how this looks and kind of copy it from there until you kind of get used to using it. This is a dotted line, so I'm going to graph it like this. This doesn't have to be beautiful. I'm certainly not making it perfect. Like that. Okay. The other one on this graph is this. This is a solid line. The y-intercept is 4. The slope is -1/2. I can draw my solid line like this. I have not used any test points yet, so I'm going to do that kind of in one step. So I'm going to use the point 0, 0 for both. I want to evaluate, is it true here? So I have 0 is less than or equal to 4, and that is true. This one says y is greater than or equal to, or sorry, y is greater than. So let's see, 0 is greater than 2 times absolute value, 0 minus 3 minus 2. Okay, the absolute value of -3 is 3. So 2 times 3 minus 2, 6 minus 2 is 4. Is 0 greater than 4? Nope. Okay, so this green line was true for 0, 0. So I can shade where 0, 0 is for the green one. Like that. The blue absolute value function said it was false. So I can't shade over here. I have to shade up above. So what's the section that's shaded by both? It's this part right here. just that triangle there. I'm going to just do a couple of these, and then I'm going to have you finish off the rest of this problem. I'm going to start by graphing these three inequalities. So I'm going to start with the red one. So my intercept is 4, slope is 1. Just kind of trying to save a little time here. So the line looks like this. It's solid because it's or equals to. Which side am I going to shade? I got to put in my test point, and I get 0 is greater than or equal to 4. That's a false statement on this side of the line, so I have to shade over here. So let me just fix that. Okay, next one is the slope is 1/3. The y-intercept is -6, so the graph should look like this. This one is a dotted line. Okay. Which side am I going to shade? You can use your test point. 0 is less than -6. That's a false statement. So this spot right here is not in the graph, so I have to shade down here. Lastly, I have y is greater than -5. Here's where y is -5. All the way across, it's a dotted line because it's not or equal to. So it's like that. Where is y greater than -5? Well, all of the values above it are greater than -5. So that's up here. Where are all three inequalities true at the same time? It's kind of just this little tiny small area right over here. It does kind of continue on forever though, all the way down this way. Okay, so the question is, which of these points is a solution? And so I'm going to start with this one. Now I know that this one isn't on the graph, but I think we can still deal with it. So here's where 10 is. So 11 is here, 12. So 12, -5 is this point right here. I'm going to do it in pen so that you can actually see it right here. Now, this line is on, or this point is on that yellow line. But remember that yellow line is dotted. So anything on that yellow line does not follow this inequality right here. Remember, if I put in -5 here, that's the y value. -5 is not greater than -5, it's equal. So this one is not a solution. Let's do one more, and then I'm going to have you do the last three. I'm going to put in, let's see, 9, -3. So 9, -3 is this point right here. Again, this is on a dotted line, but it's really close to where that green area is. If it's on a dotted line, there's no way it can be in the solution because it says it's not equal to that line. So this is also no. I'm going to ask you to pause the video, take a second, just think, what about these other 3 points? And then I'm going to just quickly talk through them. Okay, so 8, -4 is this point right here, 8, -4. Even though this one is on a line, this line is solid. And so because it's solid, that means that yes, we are using it in the inequality. So this is yes. The next one is 9, -4. 9, -4 is right here. 9, -4 is certainly inside the green inequality, so yes. And then 0, 0 is the last one, and this one is right here. 0, 0 is not in the inequality because it's not even close to that green area, so no. Okay, you have a mastery check to finish up here, and then you are done for the day.